right, I know. Okay, so here we are with the light class due to the COVID, the speaker issue. There we go. Okay, so we started right before the Thanksgiving holiday talking about hardware. Well, mostly there's threads, what kind of threads there are. We talked about kind of threads, how to make threads. We left off with thread repair. Now let's get into talking about actual hardware. So slideshow. Oh, current slide. There we go. Okay, talk about actual hardware. Now as I go through this, I'm going to talk a lot about part numbers, an AN this or, an MS that. And I don't necessarily want you to try and memorize part numbers. That's not the goal of this at all. Now you do have to understand if I said an AN 4-12 bolt, that's one of the things that you should be able to understand. But if I said, oh yeah, you're going to put an AN 365 on this thing, if you're like, I don't know what that is, that's okay. But you should be able to at least understand how they work and go together. So having said that, let's talk about, write some notes. So hardware. And since this is a continuation, it's just hardware. Hardware. What?
We're going to be able to flash with this notes.
I don't think that my speed has to do with how many people are sitting on the audience.
Yeah, you're right.
And it'll take me longer if I have to explain things like that. All right, so hardware is classified as either, well, AN, and it was a progression. So when I got into aviation, it was pretty much mostly AN and then a little bit of MS, and I'll show you that. So AN, which stands for
Army Navy.
Air Force/Navy. According to the book. Some people say, or Army, Navy. I say Army Navy, since the standard was developed before World War II and the Air Force was founded in 1947. So I think it's Army Navy, but you can go either which way. All right, so it's either an AN, or then they changed it to MS, which is military standard, or military standard, and then now they have NAS, which is National Aircraft Standard. And the sucky thing about this is going from AN to MS was really, really easy, because the most part they would just add something to it, like one of the nuts is a 365, so it's an AN 365, and then you have MS. We give it MS 20 365. You're like, oh, okay, just add the MS 20 on the front and just call it the same thing. I can do that. But then they got NAS, and now it would be like a NAS. Like a washer. It used to be like just a 960. Now it's an NAS 1149. So it's be this big old long stinking number, and you're like, oh my gosh. There's no rhyme or reason how it happens. It's just like, where did you get this? It was like, little ping pong balls coming out, and that's how you named it. So, many parts can be called by AN, MS, or NAS. So many parts can be called by AN, MS, or NAS. So you could have a part that kind of matches all of them. It's just depending on how far back you go. All right, so let's talk about bolts. So I'm going to tend to default mostly to AN or MS. It's just kind of the way it goes for me. All right, bolts. I got parts of bolts. Parts of a bolt. Oops. All right, you got the overall length. Notice the overall length goes from under the head. You don't just like a universal head rivet, right? You count it. You don't count the rivet head as part of the length. You go from here to here. And this length, what is this length called?
Oh, yeah. Nominal length.
Nominal. Hey, very good. Nominal length. So it's going to be in. What's a rivet in?
30 seconds and then 16ths.
So what's the length of a rivet?
30 seconds.
16ths, okay? And so this is going to be in eighths. And what's the diameter of a rivet? 30 seconds. This can mean 16ths. So it's just double because they're a lot bigger. So the length is going to be in eighths in nominal. I will tell you that it's common to see it a little bit longer, like if it's like an eighth comes to right here and like, oh, it's just a 16th past. Don't go the next one. They can make them a little bit longer, but they'll never make them a little shorter. So just keep that in mind when you're doing your project. So overall length is the grip. I'll write this. Parts of a bolt. We see overall length. Overall length equals the length of the grip also called the shank, plus the threads. I mentioned the grip. The non-threaded portion is the non-threaded. And of course you have the threads. Now the funny thing about aviation hardware and bolts is, you go to the hardware store, Lowe's, whatever, and you want a bolt. And say you're getting a bolt that's 2 inches long. Well, I mean, you're going to find one that's got threads down at the end, and some that are threaded all the way, and some that are halfway threads, right? It's all the same. AN hardware is designed for basically one thing. You're always going to get room for maybe 2, 3, maybe 4 washers and a bolt. That's it, done. Always the same. Now, of course, a smaller bolt will have a smaller threaded portion because the nut is smaller, so you only need so many threads. But you get into a bigger bolt, you're going to have more threads, but it's still just enough for that nut and a couple of washers. It's always that way. So unless it's a special made bolt, but that's a different kind of bolt. But standard AN bolts just have enough threads for a couple washers and the nut. See, threads, we got that. What would I have that for? B, come in different styles. Let me see. So there's many different styles of aircraft bolts. So let's talk about the standard bolt, for lack of a better term. Or we can call it the standard AN bolt. And these are one of the nice thing about AN bolts. They're still AN bolts. There is no MS number. There is no NAS. They're just AN bolts. So they run from an AN3 all the way up to an AN20. And here, as an example, we could be talking about an AN4 Hotel 20 Alpha. And you should know what that means. Maybe not right this minute, but in a few minutes. So the first number, huh?
No, there's
First number is what? Diameter. In what size increments?
16.
In 16ths. So the first number right there in 16ths. So that one happens to be 4/16, which is actually, which is 1/4 inch. It's a 1/4 inch bolt. So an and 4 is a 1/4 inch bolt. Let's see. So that means that sizes range from 3/16, because it's an AN3, 3/16 to 20/16, which is, it's a 20/16. Huh?
Oh, wait, no.
1 1/4?
Is that 1 1/4? Okay. I didn't write it down. 1 1/4. It's a big bolt. I've never seen it. Yeah, that's a big, big bolt. I don't think I've ever seen anything past a 3/4 inch. Let me see what we got here. No, I didn't want that. Let's see. Set 1, first number is, oops, that's an I. There we go. I, size of range of 3/16, and I, there we go. That's what I wanted. Sometimes a 3/16, that's the smallest, is noted or shown as a number 10. And that has to do with screws. We're going to get into screws in a little bit, but a number 10 screw is the same as a 3/16 inch bolt. So sometimes they leave that off. I showed you that last week on a little chart where it goes 8 or 6, 8, 10, then quarter. It's like, well, wait a minute, what happened to 3/16? It's number 10. All right, so we got the first number. Now we've got the indicator after diameter. After diameter. What I mean right that is like this one right here. That has an H. All right, so dash, dash, which is, you know, that thing. Dash indicates cad or cadmium plated steel. So these things aren't plain steel. They're really going to come in a couple of different flavors, if you will. So you either have the gold colored cad plating, which also there was clear cad plating for a while too, and it was silver. And that's what makes things hard. So when we were working on antique engines and we would rebuild an antique engine, we wanted to rebuild it to its actual, like how it would have been in the day. And that's just how you do antique aircraft. And so what we do is we take it all apart, we take all the hardware, we take the hardware and we send it off to a plater, and we have it plated clear, and it comes back silver. So it's like silver paint. So that gets confusing because older hardware was silver. All of the new modern hardware is gold plated. It's just a cad plating on it. But then you get into corrosion resistant steel. So C in place of a dash indicates corrosion resistant steel. Resistant steel. What is that also called?
Stainless.
Stainless. What color is stainless? Silver. So modern hardware, if you have something that's silver, it should be stainless. But maybe it's not. What else could it be? Old cad plating or newer cad plating where the gold wore off. Or aluminum. So how would we know the difference?
Magnets.
Well, what did a magnet tell me?
If it was steel or aluminum.
Steel or aluminum. So we can eliminate that. So if it's aluminum, then that's not going to stick to the magnet. To determine if it's aluminum or...
No, steel or stainless or old flat plated.
You ever see the movies they bite into something? You should be able to bite into it and see.
Like it's a nickel.
If it chips your tooth right away, then it's fine. See, you bite it and then you wait for a couple days, years, and if it corrodes, then it's cad plating.
Okay.
If it doesn't, then let's see. Oh, I wrote this note. I'm glad I did that. Okay, what about, okay, so a magnet will tell you if it's aluminum or steel. What about if it's stainless steel or not?
Yeah, it'd be non-magnetic.
What's that?
Be non-magnetic for stainless.
Stainless steel, yeah, it's non-magnetic.
Is it?
Yeah.
There's different types of stainless steel. There's martensitic, austenitic,
Oh my god.
and ferritic, I think. Let me see.
Words in that.
I only knew 2 of them.
I was gonna say, my fridge has got a
Ooh, 5. Ferritic, austenitic, martensitic, duplex, and precipitate hardened.
Wow.
Only one is non-magnetic, and that's austenitic.
Is that the one we use?
They make the
No.
refrigerators that are like stainless steel.
right?
Yeah.
But they're magnetic.
That's
I
right.
mean, you can put your magnetic stuff on it.
So I took this cool welding class. Of course, that guy said, well, there's 2. There's austenitic and martensitic. The martensitic, M, is magnetic. The austenitic was not magnetic. But it was kind of cool because he got a piece of austenitic and he got it red hot, stuck a magnet to it, and lifted it up. And then it cooled and it fell off the magnet. So that's a whole other thing. So, all right. So how are you going to know if it's corrosion resistant? It's really, really difficult, especially if you're dealing with just an old batch of hardware. Okay, well, why are we dealing with an old batch of hardware? You shouldn't be. So, you know, if it's around here and you're just trying to identify it in a box of hardware that's been around since, you know, World War II, okay, well, now we got a problem. But if you're actually out there and you're working on an aircraft and you're picking up something and it's like, well, I don't know if this is stainless or, okay, you picked it up out of the wrong box, because nowadays we're supposed to know. When you buy a bolt, it comes with a little tag on it that tells you this is the part number, has tracking and all that stuff on it, and they're expensive. And so you put it in the spot where you keep the tracking on it so you know exactly what it is and you look at the part number. So we'll say in modern world, if it's, you should know the part number to begin with when you pull it out of the bin. It's like everywhere you work, you have the hardware bin. That's just standard, you know? And so one of the places I worked, we had this, geez, it was huge. It was like 10 feet wide by, 5 feet tall, with little pigeonholes, all of them. And, and you'd take a bolt and you'd hot glue it and stick it on there, that's your example. But then in that little pigeonhole, we would always put the traceability tag or the tag with what it was, what lot it came from or something like that, so that you would actually know. So we're going to go with what should be. So dash is cad-plated steel. What color is that? Gold. C in place of a dash indicates what color is that? Silver. And then, do I have something else here? Oh, yeah.
So,
and an H. Yeah?
on the example, when you wrote the AN4H28,
Yep.
was there a dash in there that I missed?
No, let me show you. It's kind of weird. So equals a hole in the head, hole in head for safety wire. Okay, so in my example, the AN4 hotel, which one of these is it? Is it cad plated gold? Is it corrosion resistant silver? Or H is a hole in the head, so that doesn't help me with what its material is. It's like a whole other thing. So we got to go back up. What is it? It's cad plated. What if it was a corrosion resistant bolt?
You put a C in front of the H.
Okay, so we could have an AN4 hotel, which would be normal, so that'd be cad plated. Or we could have an AN4CH, which would be stainless steel with a hole in the head. Next number is overall length. Overall length. Not counting head. Not counting the head. Of the bolt in 1/8 inch increments. Okay. And it goes like this. So we'd have, let's say, a dash. I think a 3 is the smallest they make. Dash 3 would be 3/8. Dash 4 would be
Half an inch,
4/8. Or
half an inch.
1/2 inch. 5 would be 5/8. 6 would be
3/4.
7 would be. There is no 8.
Nope.
And there is no 9.
Nope. Just
Because single digit, a single digit is lengths from, we'll say 3/8 to 7/8. So what's going to come after dash 7 for 1 inch?
10.
10, which equals 1 inch 0/8. So we'll have 11, which would be 1 inch 1/8.
So you only say 3/8 to 7/8. Does it go below?
A single digit. A single digit.
Yeah, but like it's
Lengths.
dash 2 dash 1.
Dash 2 dash 1.
No, like dash 2 or dash 1.
No, there's no such thing.
Okay.
So dash 10 will be just 1 inch.
Dash 10 is 1 inch 0/8. So a double digit. Double digit. First digit is length in inches. Second digit is length in eighths. All right, so we got 12, which is 1 inch and 2/8. 13 is 1 inch, 3/8. All right, on and on and on. Dot, dot, dot. We'll get to, so there's 14, 15, 16, 17 is 1 inch, 7/8. What's next?
20.
20. 2 inch and 0/8. So if you really want it, well, we had the tool room guy. I would beg you guys, please go ask for a dash 8 or a dash 9.
I'm still trying to.
Can I scroll down now?
Hold on.
Yeah, I'm gonna double vision.
All right. Let's see. Links come in. I wrote dash 3, 2, a dash 80. How long is a dash 80? 8 inches. That's not hard, is it?
Nope.
Okay. Standard bolt. Has a asterisk or plus on the head. Let me see here. So aircraft bolt heads have indicators on them. Now you kind of have to watch for this because you might see something like this little plus right here, and it may have, you know, an A here and a C there, and you go, well, I don't know what those mean. Well, manufacturers have codes that they're going to put on there. So don't let the manufacturer code mess you up. You know, this may have a, you know, little star over here and, you know, a circle right there. It doesn't mean anything.
It's really just what is on.
Yeah, you're looking for the main identifier. Like this one right here has an asterisk, says A in there, and has a C there. That could mean corrosion resistant. That one's got a 4. I don't think the 4 means anything. So you can see how It just kind of works like that. So you're looking for the main identifiers. You know, definitely special. That got an asterisk, asterisk, asterisk. They're standard bolts. A plus, standard bolts. Close tolerance has got the triangle. That means something. All right. That's just special. But you got to watch because it's got an X. It could be a plus. So sometimes you get kind of weird like that.
What is it when the X is just on the bottom, like to the left of the S? So it's not in the center, it's just in the dead, it's in the middle on the bottom instead of
Like
in
right
the
there?
center of the ball.
Well, it could be a plus.
You never know.
You just don't.
Depends on how you hold it.
Yeah. Yeah, I'm sorry. I don't have a good answer for you. Sometimes they put stuff on the board like, I don't know what the heck this is. That's why it's important to know what it is before you use it. And it's one, like I said, one thing to do the AN hardware project, and like, I don't know what this is. It's a whole nother thing when you're actually putting it in an aircraft. You go, I don't know what this is. Well, you shouldn't be using it. That's just the way it works. If you got a bolt and you're like, I'm not totally sure, okay, it's gone. Boom, trash. Give it to somebody else. Use it to hold, you know, parts together on the tug or something. It does not belong in an airplane. The only bolts that should go in an airplane are absolutely, especially nowadays, you know, back in the day, I mean, it was just, you just get a box of bolts, like, oh, look at that. You're expected to use them. But nowadays, everything comes in a package, everything has a number on it, it's traceable, and you should know. So, you know, if you're holding, I don't know, it's going to be careful. So if you're holding something that just doesn't matter and you're not worried about it, well, I guess that's one thing, but, you know. Hey, I'm using this to hold the wing on. I'm not sure, you know.
You're using this to hold the prop on.
Yeah. Looks like the other ones. Okay, then don't use it. It's just that simple. Know what it is. All right, what do we got here? Standard bolts, lengths. I got that.
We did the last part of the
Oh my gosh. We have to write down everything.
second digit is, more. You're moving fast. Second digit is.
Second digit is lengths in 1/8 inch increments. Got it? All right, there's something I forgot here. Okay, then you have, back up here. All right, so nominal length, right, is not counting the head. Grip is right here. Notice how some of them have a hole and some do not. So an A after the part number means no hole or absent the hole. So A is absent the hole.
How would you safety that? If it had
Well,
holes
I'm
on
glad
it?
you asked. So at some point I get into it, but I think I'm going to jump right into it right now. All right, so let's talk about that. A couple of rules, and at some point I'm going to write this down again. But I want you to know these rules. Number one, most aircraft are aluminum parts and aluminum structure. These are made out of
Steel.
steel. Okay, let's keep that in mind. Aluminum on steel. You don't twist aluminum onto steel or steel onto aluminum. The steel will win. I can guarantee you these cheap little bolts are worth not as much as whatever you're trying to bolt together. So you never twist steel against aluminum. So if you've put this together, you got a nut on one end and you're tightening it up, you should have a washer. A washer protects the product from damage, especially if using a lock washer. Okay, everything in aviation has a safety. It's one way or another. not everything. Most things in aviation are safety in one way or another. All right. So what is a safety? Well, maybe it has safety wire holding a bolt. Maybe it has a cotter pin, a self-locking nut, or a lock washer. I think I covered them all for the most part. Those are your main ones. So lock wire, lock washers, locking nut, cotter pin. All right. There's also PAL nuts. So I say 5 PAL nuts, but those are pretty rare. All right. So you're always looking for something safety. Now, I'm trying to think of things that aren't safety on an aircraft. And the only thing that I can think of off the top of my head that is not safety, our cylinders are not safety onto an engine because they're torqued at such a high torque value that they just don't back off. Well, but they're not torqued. I mean, sorry, they're definitely torqued. They're not safetied. And that's steel on steel. And so there's no washer either. So it's just the steel cylinder with a nut. But okay, everything else pretty much has a safety. I cannot think of any exceptions to that. I'm sure there are, but I just can't think of it on top of my head. So you're always going to look for a safety. So if it has a hole, what is that hole for? Right here. For a cotter pin. You could use safety wire in some applications, but as a cotter pin. If it doesn't have a hole, what kind of nut would you use?
Self-locking.
Self-locking or a regular with a lock washer. If you use a lock washer, you must always use a regular washer. Because a lock washer digs into the base metal. And this is the funny thing. I think I got a slide here. Apparently I don't.
When you say A after the part number means no hole, you mean no hole in the shank or no hole in the head?
No hole here in the shank. Must be my 309 slide. It is. All right. So we'll get into that. So always look for the safety. Okay. Back to our regular schedule program. All right. So we have standard A and bolts. If there's an A, is it hole or no hole?
Absolutely.
No hole. If there's a hole in the head, how is that indicated? Where's the H go?
After the diameter.
Place of the dash, after the diameter. Very good. Okay, so I expect you to know this. So the AN stands for Army, Navy, Air Force, Navy, whatever. The first number is going to be diameter in what increment? 16ths. Okay, 16ths. The bolt material, what kind of bolt material is that? Cad-plated steel, which is what color? Gold. If it's got a C, it's stainless steel, corrosion resistant or stainless steel, same meaning. And what color is it? Silver. Okay, it's one of those two things. How long is this bolt here? 2 inches and 0.8. Is it a little more than 2 inches or a little less than 2 inches? It's always a little more than. They don't cut them short, they cut them long. And the A means that no hole. Okay. Yeah, when you're bolting stuff together, ideally you're supposed to have whatever you're bolting together is the grip part, right? And then you put a washer. I want a different color for washer. There. Washer, cad plated steel. Got a washer, and then the nut goes on. Castellated nut. Well, that's terrible. Castellated nut. So you don't want the threads inside of what you're bolting. Hopefully that makes sense. Yeah, so the threads shouldn't disappear up into what you're bolting. Why? Because all the stress is really mostly concentrated right here on, I should be using gold now. All the stress is concentrated right here in this first thread. And it's just a matter of the way the bolt is. So you don't want what you're bolting together and all the stress to be met at this exact same spot where you could have some shearing action going on there with the stress and get rid of it. Most of the time it's just engineered where you don't have to worry about it. These bolts aren't necessarily being used to their final kind of yield torque, if you will.
The same, like you don't want the threads to stick out too much? Or
Well, you can't. If the threads stick out, well, okay. Yeah, you don't want the thread to stick out too much because you're only allowed to use an 1/8 inch worth of washers.
Okay.
Yeah, there's a minimum. I say 4, but I think I've seen some things said 4 and some things that are like an 1/8 inch. But if you're using 4 washers, you got the wrong bolt.
Yeah.
You know, if you've exceeded 1/8 inch of washers, it's like, well, get the next bolt size down, which is 1/8 of an inch less. Okay.
But you wouldn't need a washer right after the head either, or you wouldn't need one?
I do. Yeah, depending on the application, I'll use 2 washers. I'll put 1 washer underneath the head. Always 1 washer here. Always, always, always. And then maybe you have the lock washer comes next. So it's washer, lock washer, then the nut. Okay, the next thing we'll talk about is our AN 173s through 186 close tolerance bolts. Now you have to imagine here, or don't imagine, I don't care, but it is a fact, that when they make standard AN bolts, they're made in mass production. They're the cheapest bolts. I think they only sample them and destructive test a sample of a lot to see how well they're going to do. It's not uncommon to see one of these things, in the bag. You open up like, he can't use that. The threads are munched somehow, or CAD plating's missing on something. They're mass produced, right? The quality is okay, but it's not that great. And so if I'm bolting something together, let's think about bolting your wing to your airplane. You're going to have 2 holes usually that are part of the spar that comes through, and then the wing is going to come through with another component there, and so you have a bolt that goes through 3 holes. Okay, if I have a bolt that is kind of the right size, because these things are going to have a tolerance. They can be, this as small as this or as big as this, and still call it an AN4. Okay, so there's this range that they're made in. Well, what if I got a bolt that was made on a Friday when everybody was trying to get out of there, and it's a little bit too small, but I use it in that wing fixture? What's my wing going to do?
Vibrate.
It's going to bounce back and forth, and as it does that, it stresses out the bolt every time it moves. And eventually it might shear that bolt off or work the hole get bigger. Hole gets bigger, the wing's all slot. I mean, nobody wants a wing that's bouncing back and forth, right? That's kind of spooky looking. So they make different bolts. Now this particular one is a close tolerance bolt, which means that it's made to more exacting standards. So they're going to make it and then they're going to grind it to an exact size. Most of the time, I want to say they're not CAD plated right here. I think the CAD plating is actually off of it because the CAD plating is an unknown thickness, and they want it to be the exact right size. So this one indicates that it is CAD plated, but I've seen more expensive ones not CAD plated, and it looks like somebody took a bolt, stuck it in a mill, and actually precision ground it to the right size. So a bolt like that's going to fit exactly in that fixture I'm talking about and allow no slop. They're much more expensive because there's some labor that goes into making these things and the quality control and everything else. So it's not a standard A and hard, it's a specific bolt, a close tolerance bolt. Like I said, you'd see these on things like wing fixture, wings and stuff like that. So that's the 173 through 186. Now I don't expect you to remember 173 through 186, but there it is. Let's see. So I've got the close tolerance. Talking about different types of bolts. This is our second one. So close tolerance. That is the AN 173 to the AN 186. I have it as a 0.0005, half of a thousandths tolerance. So it's made to half a thousandths tolerance. So the diameter.
Would that be plus or minus, or is that?
No, that'd be a thousandths then. So it's got to be this. Can't go more than half a thousandths off what you want it to be. Diameter in 1/16, 1/16. After the AN 17 part, or the 18. So AN 173 would be 3/16. AN 174 would be 4/16. So you can just keep going because you're going to get to AN 178, 179, 180, 186, and you're going to add the 16ths. Lengths. is same as AN bolt, which is to say it's in eighths. Marked with a triangle. Used in applications where the bolt is an interference fit. Where?
You need like a hammer to get it in.
I was going to write that. Where bolt is an interference fit. Hammer fit. Let me think. 0.00. If you have two machine surfaces, like a piston pin, which is highly polished and machine fit, going into something, a 0.003 looseness between the two parts. This is just off memory, so you don't have to write this down. Is some slight movement. So if you put those together and it's a 3/1000 fit loose, and I put it in there, and you can wiggle it, you can just barely perceive a little bit of movement. And 0.002 is going to be no movement. No movement, and it's going to be temperature sensitive. So in other words, if one part is hot and one is cold, but they're the wrong way, like the piston pin is hot and the thing it's going into is cold, you may not get them together. But if they're both the same temperature and they're lubricated, you can barely push it in. So no movement. That's a hand fit. Hand fit, which means you can press it in by hand. 001 is a press fit. You're not going to get in that by your hand. One of them's got to be hot. You'd have to use temperature differential, chill the part going in, heat the other one. But it's a very tight press fit. And then when you get into an interference fit, that actually means that the part that is going in is literally bigger than the part that it's going into, which is going to have to displace some sort of metal. So that's technically what to me what an interference fit is. But this is just kind of a side note, if you will, based on my experience in the machine shop. So you could actually, you didn't have to measure stuff sometimes. You could just put it in and just go, oh, that's about 2.5. And then you'd measure it and like, yeah, that's about right.
What would be the point for the interference?
You don't want it to move. Okay, well, like in engines,
Bigger, right? You're saying?
okay, in engines, you haven't had engines yet, right?
No.
Okay, we have the connecting rod. So the big end goes on the crankshaft, and the small end is where the piston pin goes in. There's a bushing that goes in there. There's a lot of parts where a bushing goes in. The bushing is actually bigger than the part it's going into. So when you push it in there, you use a press to get in there, so it can't come back out. So bushings are all press fit. Why would you want a bolt to do that? Just in my wing example, it's more around this area right here, the 2/1000s to 1/1000s. It's actually smaller than, but it's just such a tight fit that you actually have to hammer it in because you want zero movement, relative movement between those things.
Those areas probably get a lot of vibrations too. That's why it's so close or so much.
Well, wings, it's not a vibration. You just want zero movement.
Yeah.
You start to get movement, and then it's going to start wearing out. Then once it starts wearing out, then the hole gets really big.
Yeah.
And it's subject to damage.
And your wings are flat.
Well, I could write this, and this is exactly what you just said. Used where two parts are bolted together. Two parts are bolted together and subjected to load reversals and vibration. All right, next up is the drilled head bolt. So the AN bolt with an H, AN4H, has how many drills in it?
One.
One. They just ran it through once. The drilled head bolt, boom, this one, hole on every single one. Okay, and the reason for that is for safety wire. Now these are going to come in both fine thread and coarse thread. Everything else is fine thread. AN bolts only come in fine thread. I guess I could have wrote that. These come in fine and coarse. I believe the 73 is fine and the MS20074 is coarse. That's how they're identified. So these particular bolts, what is this hole? The holes up here for?
Secondary wire.
Okay, so how would I safety a nut then?
You wouldn't.
Why not?
Use a self-locking nut.
Okay, these were really not made for nuts. Doesn't say that. The nut will certainly go on it just fine, but their application was not designed for a nut to be used. It's going into a blind hole. Does everybody know what a blind hole is? A blind hole is where you have a part. Well, it doesn't have to be a blind hole. You have some sort of part. It's there and it's got the threads in it. This is a big part here. And then you're going to bolt something to it. Something blue. So we got something we're going to bolt to it. All right. Got to imagine this is just one piece here. Right? And then the bolt comes through and it's threaded in there. You got the bolt head and it's got the little safeties through it. Terrible to draw, sorry. All right, so there is no nut because the bolt actually just went into the part and the part had the threads. So that's what it's designed for. Now I can run the safety wire through here to something else.
The part was the nut, basically.
The part is the nut. Oh, that's good. So the part itself is the nut. So that's why I got the safety wire on there. So, of course, we don't forget to put a washer in there. Always got to have a washer. Almost always. All right, so MS20073, 73-14 dash, I'm sorry, 04-14. So it's kind of the same as we've already learned. It's, that right there is in what? Diameter in? 16ths. So it's 4/16 by 1 inch and 4/8 or 1.5. Yep. Same as an AN73 up to AN81, but that's the newer number. All right, so let's see.
So there's an extra 0 in there. Does that count? It says MS20073.
There's also a 0 in front of the 04.
What?
In the book it was just dash 4.
Do I have too many zeros?
I don't know.
Or
I'm just,
No, I think it's the MS273. I really do.
oh,
That's what my book says too.
200?
Yeah, 20073.
Yeah.
Yeah, it's just the O in front of the 4 is what's
What?
in the book.
Here, right here?
Yeah.
Oh, it's just the way they did it.
Yeah.
So yeah, don't let that. So drilled head bolt. That is the MS20073. I'm going to put fine thread. Fine thread, and I'm pretty sure it's the MS20074 is coarse thread.
So those are only MS, those aren't like an AN type?
Okay, so this was also the AN73 to
Oh, yeah,
AN81, but it's confusing with the fine and the coarse thread in there. So that's why I go with that one with the MS number. It makes much more sense.
And you are correct about the MS 20074. It says it's national coarse thread. It's principally used for aluminum and magnesium castings.
Nice.
Yes.
Uh-oh. I just messed up my notes here. Why is that? Oh. No, it's break time anyway. I can fix my notes.